Understanding the basic terminology related to the data structures is essential for effective communication and comprehension in computer science. Here are some fundamental terms: data structure, a way of organizing and storing the data to perform operations efficiently. Element, a single unit of data, the smallest identifiable piece of data in the data structure. Node, an individual element in a linked data structure, such as linked list or a tree. Head, the first node in a linked list. Tail, the last node in a linked list. Root, the topmost node in a tree data structure. Parent, a node in a tree that has one or more child nodes. Child, a node in a tree that has a parent node. Sibling, nodes in a tree that share same parent. Leaf, a node in a tree that has no children. Level, the depth or distance of a node from the root in a tree. Depth, the level of a node in a tree. Height, the length of the longest path from a node to a leaf in a tree. Edge, a connection between nodes in a graph. Graph, a collection of nodes connected by edges. Vertex, a node in a graph. Directed graph, a graph where edges have a direction. Undirected graph, a graph where edges do not have a direction. Weighted graph, a graph where edges have weights or costs. Adjacency, the relationship between two connected nodes in a graph. Array, a collection of elements stored in a contiguous memory allocations. Linked list, a linear collection of elements where each element points to the next one. Stack, a data structure that follows the last in first out principle, that is LIFO. Queue, a data structure that follows the first in first out principle, that is FIFO. Hash table, a data structure that allows efficient insertion, deletion, and retrieval of data. Binary tree, a tree data structure where each node has at most two children. Binary search tree, a binary tree with the property that left subtree of a node contains only nodes with the keys less than the node's keys, and the right subtree contains only nodes with the keys greater than the node's key. Algorithm, a step-by-step procedure or formula for solving a problem. Time complexity, a measure of the amount of time an algorithm takes to complete as a function of the size of the input. Space complexity, a measure of the amount of the memory an algorithm uses as a function of the size of the input. Understanding these terms provides a solid foundation for delving into the world of data structures and algorithms in a computer science. So, in this video, we have learned the basic terminologies used in the data structures, and they are data structure, element, node, head, tail, root, parent, child, sibling, leaf, level, depth, height, edge, graph, vertex, directed graph, undirected graph, weighted graph, adjacency, array, linked list, stack, queue, hash table, binary tree, binary search tree, algorithm, time complexity, and space complexity. We will be learning all about these in depth in upcoming chapters.